I arrived yesterday lunchtime, and at that time I still thought that I was very smart. And then I started to meet with and talk with some of you folk. And I was transported back 20 or so years to my time at university. You know, I recognized some of the t-shirts and some of the haircuts and some of the really enthused conversations, technical conversations that were going on. You know, even the accents were right. I don't know if Dave and Rob are here, or AJ with their British accents. Is there anyone here from Great Britain? Yeah, thank you, one or two. So I felt very much at home. But what was different between the real 20-odd years ago and yesterday was that I am now the guy in the class that can't quite keep up. Now, you might think that I wouldn't be so enthused about being here because of that. But you know, if anything, I'm even more excited because it shows to me, it reaffirms to me that this is exactly the mix of audience that I should be talking to now at exactly the right time in exactly the right location. Now, I'm going to be talking about flattening the network. However, my objective is to pique the interest of some of you in coming and joining me and some of my colleagues for a Birds of a Feather session in Denver in June. So if I was a real optimist, I would hope to make every single one of you agree with my view of the world. But in 20 minutes, my objective is just to pique your interest. You don't have to agree with me. I just would like to ask you to start thinking about what I'm going to talk about. And I hope come and join us for a bit more of a technical chat in June at a Birds of a Feather session. Now, here we see a very familiar graph to many of you, and I'd like to thank the University of Minnesota for some of these figures. You probably know the University of Minnesota, Swanson Gilder, and of course Cisco Systems. Now, if you haven't seen this exact graph before, and this is a logarithmic one, you'll have seen something like this. This is one from our colleague Luke Coupens from Jupiter, and this one's a linear scale. But you know, whether you view the great increase in bandwidth demand that we've been seeing and continue to see as being logarithmic or exponential or some kind of Moore's law equation, I think we can all agree, can we not, that the rate of growth of bandwidth demand is growing. Yeah? The growth is growing, the growth rate, therefore we're talking about an acceleration, in which case we need a great more bandwidth supply over our networks. So where's this demand coming from? Would anyone like to shout out one or two answers? Where's this great demand coming from? Well, I'd venture to say, thank you, I'd venture to say that not only are the early users of the Internet now using far, far more bandwidth than before, but we're even seeing Uncle Bill and Auntie and Granny, who would never have thought of using these technologies in the past, now on Facebook, now in social networking, now watching videos on YouTube, now watching even uploads of videos of their own grandchildren living perhaps thousands of miles away. And just as an example, I was on YouTube, now owned by Google. I gather there's quite a few Google people here today. Good. And I watched this entire episode on YouTube, full screen, 4:3 aspect ratio, at 480 interlaced. In other words, I watched it over the web, on YouTube, at the original broadcast definition. I mean, it's just fantastical. So, if all of the middle class and upper class people in the Americas, if all the people who can afford it decide to jump on the web at the same time, well, you all know better than me. The amount of bandwidth that we're going to be being asked to provide over just the next few years, it is going to be absolutely gigantic. And it actually reminds me as well that I was watching my own television series, 24. People familiar with a show called 24? Kiefer Sutherland plays Jack Bauer. It's run for a fantastical 8 seasons, right? In this day of advertising and competition between the satellite channels and the cable channels, 8 seasons is just incredible, you know? And I think I've got our friends at Cisco to thank for that, because they were funding it. And I've got a wee request for those of you from Cisco. If you can put up a little bit more money. I understand that the feature film is held up by Fox at the moment because they can't afford to fund it. But the point I'm trying to make here is, I watched almost all of the season 8 of 24 on the Fox website in high definition. So I think I've laboured this point enough. We're talking about a fantastical amount of bandwidth that's needed. And unless there's somebody in the audience, and please tell me if there is, who's going to have a petabit router on a single shelf within the next few years, we're going to need to find another way of getting more bandwidth out of our networks. What I'd like to do is just take a moment to look at a slide of a summary of just my view of the situation just now. You know, we have a situation where we get very high volumes of video and internet traffic that's negatively impacting our profitability. We've got growing meshes of core routers to handle this ever-increasing traffic. And, most importantly for what I'm talking about just now, we've got separate IP and transport domains with very, very little cross-domain visibility. And what I'm suggesting today is that we get to a situation where we have a new architecture that leverages all of the technologies that we have just now. That is, integration of the optical domain into the IP domain with some form of cross-layer visibility and automation. And what I'm saying is that we need to get smart. We need to look at the bigger picture. By me, I mean the vendors. And if we're going to be helped, it's people like all of you upon whom I'm relying to design our new networks. I'd like to take a quotation from last week's State of the Union address. We need to out-innovate, out-educate, and out-build the rest of the world. Innovation doesn't just change our lives, it's how we make a living. In other words, the President of the US has an implied warning there. If we don't innovate our network designs, someone else will. So here's all of you up on the top floor, the third or the fourth floor, according to this diagram here, running networks, designing the networks, designing IP networks which are robust. Indeed, I believe that you have to build in IP layer protection just in case something goes wrong down the stairs in layer 1 or layer 2. Is that correct? Just to be safe? Why is it that you have to do that? Well, it's because we cannot easily see or even control what's happening downstairs. And this is a good cue for the entrance of OTN, Optical Transport Networks. And I know this was introduced this morning by Greg Hawkins and Brent Van Dussen when they were giving their excellent presentation about 100G. Many of you have already heard about OTN. Some of you may not have heard it before. What's important for me to tell you today is that OTN has come of age. We now have the introduction at the end of last year of the standard for ODU Flex. So now we have a technology which is just begging to be utilized for IP networks. Just very briefly, for those who have not heard of OTN, two great advantages. Firstly, it's self-timed. And the second thing is that it's got variable width pipes, if you like. You can choose the bandwidth that you need for each and every application. But that's not all. We now have the ability to take VLANs or other IP traffic and groom it at several levels, port level, subport, lambda level, and to encapsulate this traffic in pipes that have bandwidth of our own choosing. By that I mean we can have transport pipes that can be any size at all between 1.25 gig and 100 gig or even 400 gig. Yeah? We can start it with only 1.25 gig and we can increase in increments of 1.25 gigabits per second in increments that you choose. And that's massive, I believe, in my opinion. Now, I'm saying that you can do it, not them or us. It's because I'm talking about changing the network, you changing the network from this, and that is not correct, from this, where we have an independent IP and optical domain, to this, a single, unified control plane where you, our network designers, have control not only over the routers and the switches, but over all of the assets in the network. So what I'm talking about is a network that uses all of our technologies to optimize the entire network rather than just local areas, bottlenecks, local requirements. And my friends, this is not a zero-sum game where you have to choose between one technology or another. Let me just exemplify. I want to mention my daughter because she's watching just now. 2-3 nights ago, my daughter, who's 2 years old, and I were watching Bambi. Does anyone remember Bambi? Yeah? Good. Thank you. I see some tears appearing in people's eyes. At the beginning of Bambi, right, the camera appears to move through the forest before we've actually met the baby deer. And we see a lot of small animals. And there is a point where Mama Bird lands in the nest, and there's 3 little baby birds. And she drops in a twig with 5 berries on it. And then immediately, 2 of the birds grab the ends of the twig, yeah, and they pull back and forth between each other, which is, of course, a zero-sum game. One of them is going to win, and the other one's going to lose. But while they're busy struggling away, the 3rd little baby bird comes up, and he eats all 5 berries, leaving the other 2 looking rather stupid. So what I'm saying is, this is not a situation where you have to choose between one kind of network or another kind, one kind of protocol or another. What I'm saying is, why not use them all, and why not control them all yourselves in one single cross-domain control plane? Now, I know historically you've all relied upon the OSI model protocol stack since 1984 and before. I had a breakfast discussion with several people this morning at the Newbies conference, and we talked just for a few minutes about how the protocol stack is used these days, and it's still extremely relevant in their opinion, in that it gives a means that people from different companies, from different expertise can continue to understand what each other's talking about. But they also mentioned to me that some other things are starting to slip in, expressions like layer 2.5, yeah, or layer 0, yeah. I mean, what's all that? What's all that about? There's no such thing in the 84 or even the 94 protocol stack. But the point they were trying to make to me is this, that the world has changed a little bit over the last quarter century, and it's not quite so easy to put things into the perspective of the original stack, if you like. So this is an opening, in their opinion, to form something round about layer 3, layer 2, layer 2.5, I don't care, layer 2.1, where we can make what I'm showing on the screens just now actually work. Now, I have to say, it's going to be rather a difficult transition for people back in the company where I work. I mean, let's face it, human beings are usually happiest in an environment where they understand everything that's going on. However, I believe that most of you who wish to, who gravitate towards this solution, will be the ones who design the new protocols that will assure the jobs of me, you, and many, many people for quite a number of years going forward. Because, just to paraphrase the State of the Union speech, if we don't do it, somebody else will. Now, here, I've just picked out some of the... actually, let's have a look at this for a moment. This is just an example of 3 nodes. And you see, this is not a God box. This is 3 separate shelves, if you like, at a particular node, quite discrete. And at the top, we've got the very, very intelligent router, right? The router with the big power, the big CPU that does the real thinking. Beneath it, we've got something that's the bandwidth manager. That's what analysts call cross-connects these days. So let's just call it cross-connect. And beneath that, we've got the not very bright at all optical box or ROADM or DWDM box. And if, as in this example, this particular stream needs the processing power, by golly, it goes to the very intelligent, very useful router. In this example here, we've got the same 3 nodes with something which has already been predetermined by this control layer not to need that level of processing. And if we go to here, we may even find that sometimes at some nodes we don't even need one of the boxes. For example, the cross-connect is missing from node 2. So I'm not talking about having modular systems. I'm not talking about a God box. I'm not talking about something that can do everything. I'm talking about just smartly picking out only the functionality that we need for each node in the various networks. Now, as I said a few moments ago, some people will be uncomfortable, so I just thought, with your permission, I'd like to take just a few moments to talk about some of the potential hurdles to be overcome. A number of people might argue with me, network flattening should be done at the DWDM layer, not at the ODU layer, to reduce the complexity and the number of optical cross-connects. Well, I would argue that there are situations where IP over WDM makes sense, especially when we're talking about hub and spoke flows. But there are trade-offs, and one of the trade-offs is that the provider would need to, whoever ran the network, would need to integrate both the IP and optics operations groups. And at the moment, most providers who need a clear demarcation between IP and optical domains prefer black and white interfaces from the router. That is not coloured as CWDM or WDM. IP over WDM is typically limited to metro and regional networks since, as you all know, router wavelengths which are put into DWDM must conform, usually, to very rigorous engineering rules. Belief number 2, you don't need to protect both IP and optical layers. An emphasis should be put on IP layer protection. Well, I kind of think probably that this claim assumes that optical protection would be slow since it's down at the lambda layers. Well, if this is so, it's a fallacy again, because the fact is, in my opinion, as you move down the protocol stack, things actually happen faster. However, I would argue also that 2 protections are better than 1. So it's something I'm particularly hoping we can discuss in June. Now, I have some more beliefs up here, you can see, but I'm thinking to myself, Sue Joyner, that I'll give you all my ripostes to put up on the web, for folk to read along with my slide set, because I think this would be a good time to come to my conclusion. My main objective is to get some of you interested, not all of you, but some of you interested in flattening the network. And I'm hoping that these people who think, this is interesting, let's think about it for the next few months, will then sign up to come to our Birds of a Feather session, which will be in June. Now, I'm going to be around for the next 2 days. I'll be at the Beer and Gear, I'll be at the Social tonight, I'll be around until the end of the conference on Wednesday. So please feel free, grab me, come and talk with me. If you'd like to grab me right after this, I will also give you my contact details. I have a cell phone here with me. Call me up, I'll come and meet you any time over the next couple of days. Or indeed, I'll give you my email address, and by all means, please write to me. But I do hope to see a great many of you come to the BOF session in Denver in June. But I gather we've got a few minutes for any questions you may have for me now. Any general questions, please? Okay, quick show of hands. Who at the moment is considering coming to have a good old argument with me in June in Denver? Let's see. Good, thank you very much, and I very much look forward to seeing you. Thanks for listening. Take care.